Welcome to The Explainer. Today, we're diving into a really fascinating new idea in AI architecture, one that could totally reshape how we build intelligent systems. And it all kicks off with one single, really urgent question.
For the longest time, the whole game in AI was just about scale. Get bigger models, throw more data at them, use more and more computing power. But we're kind of hitting a wall. Just making everything bigger isn't just unsustainable, it feels like we're using a sledgehammer when we need a scalpel. So the real question now is, how do we build models that are fundamentally smarter and more efficient, not just, enormous?
So, the current, and I mean brilliant answer to this has been a technique called mixture of experts, or MoE for short. Just think of it like a huge hospital packed with specialist doctors. When a patient, or in our case, a bit of data comes in, a receptionist, which we call a gate, sends them only to the one or two experts who are perfect for the job. This means the model can know a ton of stuff, but it only has to use a tiny piece of its brain for any one task. Super, super efficient.
But this model of the isolated genius has its limits. I mean, what happens when a problem is just too complex for any one specialist to handle all by themselves? Let's take a look at the cracks that are starting to show in this MoE foundation.
So, what are the big issues here? Well, first off, these experts are totally isolated. They're working in their own little bubbles with zero way to communicate with each other. The routing system is also pretty rigid. It makes a single, one-shot decision that can be kind of clumsy or even create bottlenecks. And here's the real kicker. While they're efficient when you run them, to train an MoE model, you have to load every single expert into memory at the same time. That is incredibly demanding. And finally, because they're all trained on their own, a bunch of them end up learning the exact same basic knowledge. It's just a huge waste of space and potential.
To fix these problems, we can't just tweak the old model. We need a whole new way of thinking. One that moves beyond this collection of independent contractors and starts thinking more like a real collaborative team.
And that new idea is the Adaptive Symbiotic Network, or ASN. The name itself really tells you the whole story. Adaptive means it can change and adjust on the fly. And symbiotic means its parts are literally designed to work together, to live together, like a biological system. So what's the secret sauce here? What actually makes an ASN so different? How does it pull off this vision of true collaboration? Well, it all comes down to three core innovations that completely flip the script on how an AI model is built. Okay, first up, we have symbiotic experts. Unlike the fixed, static experts in MoE, these guys can actually change their own structure dynamically. They can fire up more complex expansion modules when a problem gets tough. Second, hierarchical gating. Instead of just one gate, ASN uses a smarter two-step process. A metagate sends the problem to the right group of experts first, and then a local gate picks the best specialists within that group. And third, and this is the most radical part, a communication bus. This is a shared channel, a direct line that lets the chosen experts actually talk to each other in real time, sharing ideas and partial results as they work. And this analogy just nails the philosophical shift. If MoE is a big phone book of individual doctors you visit one by one, ASN is a collaborative surgical team. They're all in the same room, working on the same patient at the exact same time. What one expert figures out can instantly help and improve what another one is doing. It's true teamwork. So, to really boil it all down, we're shifting from a world of isolated specialists with fixed jobs to a world defined by collaborative teams and dynamic adaptation. It's a move away from just doing things in parallel and towards true synergistic problem solving. Okay, so the philosophy sounds great, but let's get down to the nitty-gritty. Let's put these two architectures head to head and really see how they stack up feature by feature.
I mean, this table just lays it all out, doesn't it? MoE experts are isolated and rigid. ASN experts are interactive and dynamic. MoE uses that simple single-layer routing. ASN uses a much smarter, predictive, hierarchical system. But look at that third row, cooperation. That's the game changer. MoE has none. They operate independently. ASN is built from the ground up for real-time cooperation, which means knowledge isn't just stored side by side,
It gets fused together for a result that's greater than the sum of its parts.
Now, this all sounds absolutely incredible. A total revolution. But we have to remember, ASN is still a proposal. It's a blueprint for a new kind of AI. And like any really ambitious blueprint, actually building the thing is going to come with some major engineering challenges that we have to figure out first.
And that's the trade-off, isn't it? This power comes at a cost. The ASN architecture, with all its moving parts and communication channels, is just way more complex to design and train. That real-time communication bus, it's powerful, but it could create a serious computational drag, maybe even slowing things down. And getting all these dynamic, adapting components to learn together in a stable way without everything just falling apart, that's the massive hurdle that researchers have to clear to make ASN a reality.
Which leaves us with this one final, really big question to chew on. For so long, the golden AI felt like we were trying to build a single, super intelligent mind. But maybe the real path forward isn't about teaching an AI how to think, but about teaching AIs how to think together. The ASN paradigm suggests the future of intelligence might not be solitary at all, but truly symbiotic. Thanks for joining The Explainer.